In problem number 10, if f of x equals 2x squared plus 1, then the limit as x approaches 0 of f of x minus f of 0 over x squared would be what? So first of all, we want to take out the f of x and plug in what it is, 2x squared plus 1. And we want to subtract from that f of 0, but if I plugged in 0 into the original function, I would just be left with 1. So I want to subtract 1. And then that's all over x squared. So when I do that, I'm going to get the limit as x approaches 0 of 2x squared over x squares cancel, leaving me with a limit of 2. Option C. I'll go on to number 11. In problem number 11, we have the graph of function f shown in the figure above. Which of the following statements about f is true? The limit as x approaches a of f of x equal to the limit as x approaches b of f of x? Well, the limit as x approaches b of f of x doesn't even exist. The limit as x approaches a, on the other hand, is 2. So that one doesn't look very good. So put question marks and go on to the next. Limit as x approaches a of f of x is 2. Well, that's true. Limit as x approaches b of f of x equals 2. Well, the limit as x approaches b doesn't exist. D. The limit as x approaches b of f of x equals 1. That's not true either. And E, the limit as x approaches a of f of x does not exist. It clearly does exist. The limit as x approaches b on the other hand wouldn't. Sorry, so this one is asking which one is true, not which one is false. And so you can see here that there's only one option that is true. The others are questionable or just outright not true. Alright, we'll go on to problem 12. In problem number 12, we have the limit as x approaches 1 of x over ln of x. If we plug in 1 to x, we get 1. If we plug in 1 to ln of x, we're going to get 0. And so 1 over 0 is not an indeterminate form. It's definitely a vertical asymptote, and so that limit will not exist. So I say 0 over 0 is indeterminate, but 1 over 0 is a vertical asymptote. Go on to 13. In 13, it says we have a piecewise defined function. F of x is ln of x between 0 and 2, x squared ln of 2 for 2 to 4. So the question is the limit as x approaches 2 of f of x is what? We just want to see whether from the left, ln of 2. So we want the limit as x approaches 2 from the left of f of x, and that would just be the limit as x approaches 2 from the left of ln of x, which is, you can just plug in the 2 there. It's not going to be undefined. That's just ln of 2. Let's plug in from the right side. The limit as x approaches 2 from the right of f of x would be equal to the limit as x approaches 2 from the right of x squared ln 2. And all we need to do there is plug in x equals 2, and we'll get 4 ln of 2. Since the limit from the left and the right disagree, then that limit is not existent. And we'll go on to problem number 14. In problem 14, we have the limit as x approaches a, so it's not a number there, x squared minus a squared over x to the 4th minus a to the 4th. So I think we want to factor. And the numerator factors would be x plus a, x minus a. The denominator would be x squared plus a minus x squared times x squared minus a. But the x squared minus a can be then factored to be x plus a, x minus a. And you can see we'll get some cancellation. Sorry, that first term should have been x squared plus a squared, and then x squared minus a squared, which we then factored. And now we're left with limit as x approaches a of 1 over x squared plus a squared. We plug in a for x, and we'll get 1 over a squared plus a squared, which is 1 over 2a squared, and that's option B.